Hey guys, welcome to this video on Python unit testing tutorial for beginners using Py.test. So first of all, what is unit testing? So according to Wikipedia, unit testing is a software testing method by which individual units of source code are tested to determine whether they are fit to use or not. So in unit testing, we perform the lowest level of testing, that is, individual units of software are tested. That means units like functions, subroutines, and classes are tested to verify if they are giving the desired result or not. Now let's discuss why should we unit test our code. So when you write unit tests, they reduces bug in the new features and existing features. So let's say if you are writing a new feature in your code, unit tests can help you to reduce the bugs which may appear during the execution of your code. Now if you write good unit tests, this serves as a good documentation for the person who is using your code. So because in unit test we are actually using the functions or the classes and testing them, so if the person who wants to use your code, he reads the test, he will be able to understand how to use your code. Also, when you write test for your code, it reduces the cost of the change in the production. So if some code goes to production without testing, and you find the bug in the production stage, then it's much costlier than fixing your code when you are developing your code. Next, unit test helps in faster debugging and faster development of your program also, because you have the idea of what should be the desired result. That means you can develop your code in a manner which is perfect for your tests. And at last but not the least, unit test helps us to better design our program. Now let's talk about the unit testing frameworks which are available in Python. So I have listed here 3 topmost unit testing frameworks which we can use to write our unit tests. So first module is unit test module, and this unit test module is present in your Python standard library. So you don't need to install any extra module in order to use this unit test module. The next module is the nose module, which is not there in the standard library, but it's simpler to use than the unit test framework. And at last, you can use the Py.test framework, which is not in the Python standard library, but it's one of the most popular unit testing framework for Python. So we are going to use Py.test for the unit testing of our Python code. So let's see how we can install Py.test package on our operating system on which we are working on. So you can install Py.test using pip. So we are going to just write pip install Py.test and then press enter, which is going to install this Py.test package on our operating system. So you can see Py.test is now installed on my operating system. So I'm going to give cls command to clear the terminal. And then first of all, I can give this Py.test command and then -h in order to get the help about Py.test. So just press enter, which is going to give you all the flags or the commands which you can use with the Py.test. So the usage is given here. You just need to use the Py.test keyword, and then you can give the options which are listed below, and you can give the file or directory name or the list of files or directories. So for example, the general options are given here. So when you give this flag -k or -k, it's going to match the substring or the regular expression which you provide after this flag. And when you use -m, this means that it's going to test the functions which have the name assigned directly to them. That means only run the test which have a given mark expression. So I'm going to try to show you all these options one by one, but let's see how we can write the test to use them using Py.test. So in here I have a Python script called math_func.py file, and inside this script I have two functions. One is a simple add function which adds two values, and other is the product function which returns the value of the multiplication of two values. Now in order to write the unit tests for these functions, I can create a new file. So let me create a new Python file, and I'm going to name it as test_math_func. So I have added this extra prefix here, which is test underscore, in front of the name of my file, which is math_func. So I'm going to just create this file. So this test underscore prefix, which I have added in front of my Python script name, will help PyTest to recognize that this is the file in which the unit testing functions are written. So it's going to go to that file, and here we can first of all import the math_func Python script, and then we can define the test functions. So the test function you can define simply as you define any other function in your Python script. So you will write def and then just start the test name with the test prefix. So test underscore and then whatever name you want to give to your test. So first of all, I want to test the add function here. So I'm going to just write test underscore add, and this function is not going to take any parameter. And inside this function, I can provide some assertion for my functions. So I can use a special keyword which is assert, and then you can call your function in your Python script. So math_func.add function, and here as an argument I'm going to provide two numbers, let's say 7 and 3, which is going to give us the result 10. So we are going to just check whether this function is returning 10 or not, and this is called assertion. Assertion means you want to assert that the function is returning the desired result. So we are expecting the result 10 when we provide 7 and 3 as an argument to this add function. You can also provide multiple asserts here. So let's say I just want to provide, for example, 7 here. You can see that y is equal to 2 is the default value of y. So here in the assert, I can only give one argument, and the value of second argument, which is y, will be taken from the default value, which is 2. So 7 plus 2 is 9. So we can just say whenever you provide 7 here, it's going to give us 9. Once again, whenever you provide 5 here, it's going to give us 7. So in this way, you can provide multiple asserts inside your function, whatever you think will come as an expected result of your function. So I'm going to define the second function, which is test product, and once again I'm going to pass no argument here, and once again I can just use this assert keyword and then the name of my library, which is math_func dot the function. This time we are going to test the product function, and let's say we just want to check the product of 5 and 5, and the expected result will be 25. In the same way, whenever you provide here, for example, only one argument, the default value of y is 2, right? So when we provide only one argument, which is 5 here, we will be expecting 10 here. In a similar way, when I provide, let's say 7 here, we are expecting the result 14 here. So once we have written our unit tests, let's try to run these tests using Py.test. So first of all, I need to go to the directory where this test script is there. So I'm going to just copy the path and then go to the terminal, and I'm going to cd to this path which I have copied, and let me just remove the script name from here and then press enter. So now I'm in the folder where my math_func.py is there and test_math_func.py file is there. So in order to run your unit test file, you just need to give this command pytest and the name of your test file, which is test_math_func.py in my case, and then I'm going to press enter. And you can see it's going to give me 2 passed in whatever time it took to execute these 2 tests. So because we have written 2 tests here for 2 functions, it's going to show us this result, which is 2 passed. Let's say we are going to expect some unexpected value. So here we have written some wrong value which we are expecting, and now when we run our test, it's going to fail. You can see 1 passed and 1 failed. And PyTest will also give you the information about the assertion failure. So the assertion failure is happened at this assertion where you are just testing 10 is equal to 18, which is wrong here. So once again, we are going to correct this. Also, let's say some developer has changed the function which you are testing. So instead of returning the addition, now I'm going to return the subtraction, which is going to break the test now. So I'm going to run the test once again, and once again it's going to give you the error, and this time it's going to show us that the result is 4, but we are expecting 10 as the result, and that's why it's failing. So once again I'm going to just fix my code, and then once again I'm going to run my test, and once again the test will pass. So let me just clear the terminal using cls command, and you can also give a flag called -v, which stands for verbose, in order to get the more detailed result. So I'm going to press enter, and you can see it's going to give us this flag passed or failed in front of your tests, and both tests are right now passing. That's why it's written passed in green here. Let's break the test once again. So I'm going to just say minus here and once again run the code, and now it will say this test is passing, but the test add is failing due to this assertion. So I'm going to once again fix the code and come to the terminal. Once again I'm going to just clear the terminal, and you can also run your test using this command. So you just need to write Py.test without giving any name in front of this Py.test, and then press enter, which is going to automatically recognize the test file because we have given the special prefix here, test underscore. This is how your PyTest will recognize that this is the testing file. So it's going to just run the test inside that file, and once again you can see it runs and 2 tests are passing. You can also give the verbose flag here, which is going to give you the more information about your tests. Now let's say we are going to remove this prefix from our tests. So let's say we just write tes underscore add, so there is no test prefix in front of your function, and once again I'm going to give the same command, and you will see only one test is recognized, which is test underscore product, and this is because we haven't provided the test prefix in front of the function. So in order to recognize this function as a unit test, you need to give the test keyword as the prefix of your unit test function. Also, whenever you change the name of your test file, so let's say I'm going to refactor the name, and I'm going to just remove the T from test, and then once again I'm going to press refactor, which is going to change the name of this test file, and now this test file name is tes underscore math underscore func, and once again I'm going to try to run my test, and it's going to say no test run in this much amount of time. So again, whenever you don't give the test keyword in front of your file name, then PyTest will not be able to recognize that this is your unit testing file. Let's go to the terminal, and I'm going to just give the cls command in order to clear the terminal, and let's give the second command now, which we have used for running the test, which is the pytest command and the name of the file. So now my file name is tes underscore math underscore py, and now I'm going to press enter, and you will see now it's going to recognize because we are specifically giving the file name in which our tests are there. So if you want to run your test inside some file which doesn't have the test prefix in front of it, you can just use pytest command and then give the name of the file, and pytest is going to recognize that this is the file in which your unit tests are there, and it will run all the unit tests in this file. So in the last video, we have written two test functions for our add and product functions, which were able to test those functions using these numbers. Now additionally, I have added two more test functions here, and these two test functions I have added to test the strings with the add function and the product function. So using this plus operator, we can also add two strings, right? So I have added the string test for the add function and the product function here. Now the first thing I want to show here is you can add any comparison operator here. So it's not necessary that you need to use this equal to operator here. You can also write, for example, greater than operator, or greater than equals to operator, or the less than operator, or less than equals to operator, or not equals to operator. So you can use all these comparison operator with your assert statement. Additionally, you can use this is keyword to test whether something is something. So using this is keyword, I am testing here that the result which I got using this add function over the strings, is it a string or not? So using this type, I'm just finding out the type of the result, and I'm checking if this result is a string or not. You can also use in operator or not in operator. So using this not in keyword, we are checking whether this string is inside our result or not. So this string, or let's say this string, is not inside our result. So this assert is going to pass because this string is not present in our result. Additionally, you can also use this in keyword, and you can check whether some string is inside your result or not. So I can also write hello in result, which will check if this keyword is inside our result or not. Now the next thing which I want to show here is, let's say you just want to run one test from here, which is test add, and you don't want to run any other test. How you can do it using command line? So you can just write pytest command and the name of your test file, which is test_math_func in my case, and then you can add double colon here and then give the name of your test. So let's say I just want to run the test add. So I'm going to just run this test, and you can see it's going to only run the first test. Let me just add -v here, which is going to show which test has passed, and you can see this test has been passed, which is test add. And let me just clear the terminal. Now the next option which I want to show here is -k. So once again, I'm going to just write pytest here, and we will once again add the -v for verbose, and you can use a special option which is -k, and then you can give any expression which you want to match using this -k option. So let's say we only want to run the add test. So we have two add tests. One is test_add and other is test_add_string. So I just want to run the test for the add function. So here inside the double quotes, I can just write add and then press enter, and it's going to run the test which contains add keyword or add string. So you can see it ran test_add and test_add_string. You can also use OR operator here. So let's say you want to run the test which contains add or which contains string keyword, and when I'm going to run the test, it's going to run all those tests which contains either add or the string keyword. So there are three tests which fulfills this condition, and all those three tests are performed, and other test will be deselected. So you can see 4 items and 1 item is deselected here. Also you can use the AND instead of OR. So I'm going to just write AND and then press enter, and it's going to run only those tests which contains add and string both. So there is only one test name which contains add and string both, which is this one. So only this will be executed and the other 3 tests will be deselected. Let me once again clear the terminal. Now the next option which I want to show here is the -m option. So once again I'm going to just write here -m, and after this -m you can provide any mark expression. So let me go to my code, and here I just need to import the Py.test first of all. So let me import Py.test, and here you will see that it's showing me the squiggly line because of my IDE, which is PyCharm. So because I have installed Py.test using pip on the command line, which is not recognized by my PyCharm IDE, that's why it's showing me this squiggly line, but I'm running my test using command line, so this will work. So don't worry about this squiggly line, the import will work. And after that, what I can do here is I can add a decorator. So I can just write pytest.mark any expression which you want to give here. So this test add and test product is for the numbers. So we can write number here, and also we can add the same decorator for the test product. And for the other 2 tests, we can just write that these tests are for the strings. So this expression is upon you. So you can give any expression here which you want to match later using -m option. So I'm going to also add this decorator over the other string function also. So we have 2 markers now. One is number and other is the string. So now after -m you can give the mark expression name. So let's say I'm going to just write number here and then press enter, and it's going to run all the tests which have the mark number, which is the test add and test product. Now let's run the test which have the mark string. So I'm going to just write string and then press enter, and it's showing me 4 deselected because I forgot this s after the string. So let me just add this s and then press enter again, and you can see it runs only those tests which have string mark on top of them. So this is the string and this is the string mark. So those 2 tests were executed and other 2 tests were deselected. Let me just clear the terminal once again. Now the next option which I want to show here is -x option. So once again I'm going to just write pytest -v and then -x. Now this -x means exist first. So whenever first failure occurs in your test, the Pytest will exit from the execution of your test. So let's just add some failure assertion here. So I'm going to add the failure here. So let's say I'm just checking the failed assertion here just to check whether this -x works or not. So I'm going to just press enter now, and you can see first test was run, which was passed, but the other test failed. So it has shown us the stack trace of the failed test, and after that the text execution was stopped. So after 2 tests, because the failure occurred, the other 2 tests which were supposed to be executed are not executed because of this -x option. So as soon as the first failure occurs, your test will exit. Now let's say you don't want to see this stack trace after the failure of your test. So this is all the information which is given to you about what assertion has failed or not. So let's say we don't want to see this. So how to just skip that stack trace? You can add -tb is equal to no, and this is going to disable the stack trace, and then press enter, and you can see now the stack trace is not printed. Only the success or the failure will be printed, but not the stack trace. Let me clear the terminal once again, and this time I want to show one more option, which is max fail. So here you can just write -max fail option and then give the number in front of it after the equals to symbol. So let's say we just write max fail 2 here, then it's going to wait for the maximum number of failure and then it will exit. So let me just run this test. So you can see all 4 tests has been executed because maximum failure we were expecting is 2. That's why all 4 were executed, because there was only 1 failure. Let's say I just make it 1. So now the value of max fail is 1 and then I press enter, and you will see after the first failure it's going to exit because we have provided max fail 1, and this is the number of failures which we are expecting. After that your test will be exited. So let me just clear the terminal once again and let me show you one more option. So this time I want to show you the skip option. So let's say I just remove all these markers from here, and now I want to add a mark which is skip. So just add this decorator on top of your test, which is @test.mark.skip, and then inside the parenthesis you can give the reason for the skip. So here you can just write reason equals and whatever reason you want to give here. So I'm going to just write do not run number add test. Okay, so this is the reason which will be printed, and when I will just execute my test once again with -v, you can see this first test is skipped. So it's not executed, it's skipped, and all the other 3 tests were executed. Let me just fix this second test so it's going to pass, and once again let me just run this test, and you can see all other tests were passed and the first test is skipped because we have added this skip decorator on top of the test add function. Also there is a skip if option available. So here instead of skip you can just write skip if. So this skip if is going to check for some condition. So let's say I'm going to import the sys module here, which is going to give me the information about the Python version I'm running. And then as a first argument, I can first of all give some condition. So I'm going to just write sys dot version info, which is going to give me the version of Python available, and I'm going to check if this version is less than, let's say, 3.3, then I want to skip this test. So I'm going to once again let me clear the terminal and once again run the test, and I see some failure here, which is here I added dot instead of comma. So you need to separate this major and minor version using comma. So this means 3.3 Python version. And once again I'm going to run the tests and then press enter, and now you can see all 4 tests were executed because this condition was not met. Now let's say I want to just give the opposite condition of that, which means I want to skip if I have the Python version greater than 3.3, which I have the Python version 3.7. Let's check it using Python command. So I'm going to just write Python version and then press enter, and you can see I have 3.7.0 version, and let's run the test once again, and now you can see this test is skipped because this condition is met. Now the next option I want to show here is -s option. So let me just make this condition like this, so this test will not be skipped, and the next option we are going to see is the -s option. So let me clear the terminal and let's see which option I'm talking about, which is -s, and this option you can use to print any output which you want to print using, let's say, print function. So let's say I want to add a print statement here, so I'm going to just add print, and then let's say I want to just print the addition of 7 and 3, and for just knowing whether this print statement has been executed, I'm going to add this string here, so we know that this print statement has been executed. So now when I execute my PyTest without the -s option first, you will see there is no print statement which is executed. Now if I just add -s here, which will allow this print statement to be executed, and now you will see that this print statement has been executed and this line is printed using this print statement. So if you want to print all the print statements, then use -s option, or you can also use the option which is --capture is equal to no, and then press enter, which is also going to do the same. So either you can use -s or you can use --capture is equal to no. So let me clear this terminal one last time, and the last option which I want to show here is the -q option, which is the quiet mode. So let me just execute this PyTest once again, and you can see all this information is printed. And when I add -q here, which is the quiet mode, you can see no information is printed here about the test, which test is passed. Only the important information is printed, which is 4 tests passed in this much amount of seconds. If I remove the -v here from here, you will see all the other output is gone and only 4 passed in whatever amount of seconds is printed. So this is the quiet mode, which will not print unnecessary information. It's going to just show you how many tests passed and how many tests failed. So this is how you can use some options with PyTest command. In this video, I'm going to show you how to use a special decorator, which is Parameterize. So here I have on the left hand side a simple function which is add, and on the right hand side I have written the test for this function, and I have written 3 test function for the add function. The first test function here tests the add function using the integer values. The second test function I have written for the string values, and the third test function I have written for the float values which I provide to the add function. Now one thing which you will notice here is I am using the same add function 3 times here in all these 3 tests, and there has to be a better way in which we just need to call this add function only once. Now you can say that why we need 3 functions. I can just write 3 assert into the same function, and I can just remove these 2 other test functions. This is okay, but still I have to call this add function 3 times to test it with numbers, strings, and the float values. And in those type of situations, you can use a special decorator which is Parameterize, in which you need to call a same function to test it with the different type of values. So here I have imported this PyTest module, and then above my test function I will just call PyTest first of all, then .mark.parametrize. So we are testing this add function which takes 2 arguments. So here in the Parameterize, we just need to give the name of these 2 arguments. You can just say that these 2 arguments will be x comma y, because I have given x comma y here, so I can just write into the single quotes x and then single quotes y, which will be the name of these 2 arguments. So this name depends upon you. You can say this is num1 and the y is, let's say, num2, or you can say this is arg1 or arg2. So these arguments names are user defined names. You can give any names which you want to pass to your function. So the number1 variable name will be passed as the first argument, and the number2 variable name will be passed as the second argument. Now once again, when you look closely to this assert, you will see the variable values here are first argument, second argument, and the result. So the same three values you need to give here. So number 1, number 2, and the result. So I'm going to just say that the third argument is result here. And then as the fourth argument, you give the iteratable list. So the fourth argument will be a iteratable list where you can provide the values of argument 1, argument 2, and the result. So inside this list, we are going to give this argument 1, 2, and the result values using a tuple. So here in the first test, I have given 7 and 3, and the result is 10. We can give the same values here. So 7, 3, and the result we are expecting is 10. So this 7 will be passed to the number 1 argument, 3 will be passed to the number 2 argument, and 10 will be passed to the result. In the same way, we can define multiple tuple values here. So the second test is for the string values. So the first argument is hello, second argument is world, and the expected value is this one, which is result, and the third test case or test scenario is 10.5 for the floating values, 25.5, and the expected value is 36. Now once you have defined this parameterized decorator, you don't need to call this add function multiple times. What you need is you just need to define the same variable names which you have defined here in the parameterize. So the first argument will be num1, the second argument will be num2, and the third argument will be the result. And then you just need to pass these values to the add function. So the first number is the first argument, the num2 is the second argument, and the result is the third argument. Now what's going to happen when you run the test is this list which you have given here will be iterated over by your parameterize function, and these values one by one will be assigned to number 1, number 2, and the result, and the same value will be passed here as the first argument and the second argument and as the result for this assert statement. And one last thing which I'm doing wrong here is I think you need to give these arguments name as the string separated by commas. So you just need to give this string separated by these commas. So the first argument of this parameterize is string, in which you define the arguments which are taken by your function to test. So num1 and num2 and the result, and these arguments are separated by commas, and all these values are inside the string. So this thing you need to keep in mind, that this is a one argument string, and inside this string you define those values separated by comma. So let's run the code and let's see what happens. So you can see now that 3 tests were run, and the first test was with the value 7 and 3, and the expected result was 10, and it passed. Second, you will also see which arguments were passed. So in the second test, hello and world were passed, and the expected result was hello world. And in the third test case, 10.5 and 25.5 was passed as the arguments, and the expected result was 36. So by using this parameterized decorator, you can just use or call your function which you want to test once, and then pass different type of parameters into it using this parameterized decorator. So that, hey guys, welcome to the next video on Python unit testing tutorial for beginners using Py.test. In this video, I'm going to show you how to use fixtures with Py.test. So let's get started. So to start with, on the left hand side, I have this student DB class. Now as you can see here in the init method, I'm just initializing a member variable which is data is equal to none, and then it has two methods. One is connect method and the other is get data method. Now this connect method takes one argument which is data file. Now if you can see on the right hand side, I have written two tests for this student DB, and I have first of all imported this class, and then I have initialized this class student DB, and then I'm calling the connect method here. Now in the connect method argument, I'm giving this data.json as an argument. So let me show you what this data.json contains. So this data.json contains the data of the student. So it has this element called students, which contains this array, which contains different data about different students. So right now I have two student data here. One is ID1 Scott pass, and other is ID2 mark and fail. So using this connect method, I'm just opening this data.json file, and then I'm just loading this JSON file as the dictionary. So as you can see here, I'm using the JSON module which I have imported at the top, and whenever I call json.load, it's going to convert this json.file into the dictionary. And then I have this method called getData, which takes one argument, which is the name of the student. Now this name I'm going to search in the dictionary which I got using the connect method, and if this name which is provided as an argument is contained in the student's data, then I'm going to just return this student dictionary. So once again, as you can see here, I'm just importing the student.db class, and then I'm just initializing the student DB, and then I'm just calling the method called connect, and in the connect method I'm giving the data.json as an argument, which is this file which contains the student data. And in the next step, I'm just calling the getData method from the student DB class, and I'm giving the name of the students here. So you can see the name of the student is Scott, that's why I'm giving Scott here. And in the next test, I'm giving the mark name, which is the second name here. And then using these assert statement, I'm just checking whether this ID which I got using the Scott data is equal to the ID which is there in the JSON file or not. Same assert I have written for the student's name and the student's result, and similar test I have written for the second name or second student, which is Mark. Now, as you have already seen, to make things simpler, I have just used this JSON file as the database file. But in real life situations, you might be having some other databases like MySQL or PostgreSQL or MongoDB or any other database, and you might want to test your database. So this same approach you can use whenever you are trying to use the real database. So let's first of all run these tests and let's see what's the result here. So I'm going to just run these tests, and you can see both tests passed here. Now let's talk about the problems with these two test cases. Now you might have already guessed that we are repeating ourselves. So we are initializing this database twice for the two tests. But let's say we have thousands and thousands of tests. Then you have to initialize this database 1,000 times. So the first problem is the code repetition. The second problem is whenever you want to initialize your database, for example, 1,000 times, these initializations are resource intensive. So they will be costlier to your system on which you are running these test cases because they are consuming your resources. So what can be the solution here? So you can use two types of solutions in these type of cases. The first approach is by using the setup and tear down methods. Now this setup and tear down method falls into the category of classic XUnit style setup. If you are familiar with other testing frameworks like unit test or nose, these methods might be familiar to you. So first of all, we will see how to solve this problem using the setup and tear down methods, and then we will see how to solve this problem using PyTest fixtures. So we already know the problem. So to solve this, there is a method called a setup and the teardown module method. So I'm going to just write setup underscore module, and this takes one argument, which is module, and then here inside this method you can initialize your resources. So let me define a global db variable, and I'm going to initialize it with none, and then I'm going to just use this initialization inside this setup module. So whenever you write this setup module as it is, then PyTest is going to understand that this is a setup method, and it's going to execute this code before executing your tests. So what I have done is I have defined the global db variable. That means I need to indicate inside the setup method that this is the global variable, and that means now inside this db we have our database instance. So we don't need this initialization in these two test cases now. And now we can use this db instance to call the get data method to get the data about particular student. So this is the setup module method. There is also a teardown method which we can define here. So just write def teardown underscore module, and then inside the parenthesis you give the module as an argument, and inside this teardown module you can close your connections or free your resources. Whatever you want to do after your test, you can do in the teardown module. So I don't have any close method inside this database class, so let me create some dummy close method here. So I'm going to just say def close, and then I'm going to just use pass here. So it's just a blank method, and let me just provide the parenthesis here. So let's say we want to use this close method to free our resources or close the connection with the database. You can do this by just calling this method. So db.close, and this is going to free your resources. And let's just print something here so we know that these two methods are called. So here I'm going to just say that this is a setup method, and then inside the teardown module method we are going to just replace this setup by teardown. So we know that when this setup method is called and when this teardown method is called. So once again, this setup module and teardown module will be recognized automatically by your PyTest, and then this code will be called at the starting of your PyTest, and this code will be called at the end after all your tests have been passed or failed. Then this teardown module test will be called. So let's run the test once again, and you will be able to see that this setup method is called first, and after the execution of the tests, this teardown method is called, and we can recognize it by using this print statement. Now, if you haven't already recognized, I have used this -s or -s option to allow the print method to execute this print statements. So if you want to allow your print statements to be printed on the console, you need to use this -s flag. To be more clear, I'm going to just remove the -v from here so it will be more clear. So you can see setup is called first, and then you will see two dots here, which means two tests has been executed, and at the end this teardown method has been called to free any of the resources which you might want to free or close the connection with the database. So this is called the setup and teardown method. Now let's talk about the Python fixtures. So instead of using the setup and teardown methods, PyTest allows us to write the Python fixtures, which will automatically be called at the starting and the end of your test. So instead of writing all this code, what I can do here is I have first of all imported this PyTest, and then I'm going to define a method which I will call db, because as you can see here, all these tests are just using the db instance. So we want to somehow pass this db instance to our tests, and then I'm going to provide these parentheses, and inside this method I want to do the same. So I will just call this setup code here, and let me just remove all this code from here. And at the end, what I want to do here is I want to just return this db instance which I got from the student db class. I don't need this global declaration here because there is no global variable. And for now, let's just comment this code. So to declare a fixture, you just need to add this decorator at the top of your method, which is pytest.fixture. And now what I want to do here is I want to pass this db instance as an argument of both these test cases. So now what will happen is PyTest will recognize that this is your fixture, and then whatever you return from your fixture will be passed using this argument to your test cases. So let's run our test and let's see what will happen when we run those tests. So you can see both these tests has been passed, but you will also observe one more thing. And this is that this setup is called twice, which is a problem as we have discussed. We don't want to call this setup twice. We just want to call this setup at the beginning of our tests. So how to solve this problem? So to solve this problem, we can tell PyTest that this is a module wide fixture. So we just want to call this fixture once at the starting. So to do this, we just need to write scope is equal to, and then just write module here, and then we are going to just run our test once again. Let's see what happens. So now you can see the setup is called only once, and that's what we wanted, right? We just wanted to call this setup at the beginning of our test and not at the beginning of each of the test. Now let's see how we can add the tear down functionality. So I'm going to just use this code after this return, and then I'm going to uncomment this code, and then let's remove this commented code. And to call this tear down code, which is written here at the end of your tests, what you can do here is you can replace this return by yield. So when your test will start, it's going to execute the code until yield, and at the end of your test, this code will be executed. So let's see what will happen when we run the code once again. So let's just call the PyTest once again, and you can see setup has been called, and at the end of your tests, tear down has been called. So let me just clear the terminal and let's run this pytest command once again without -v verbose, so we will be more clear. And you can see, first of all, setup has been called, and then your test has been executed, which are indicated by these two dots. And after your tests, this tear down code has been executed. So this is how you can use fixtures and setup and tear down methods with your PyTest test cases. Hey guys, welcome to the next video on Python unit testing tutorial for beginners using PyTest. Now in this video, I'm going to show you how you can run your tests which you have written using PyTest inside your PyCharm IDE. So till now, we have been running our tests which we have written using PyTest on the command prompt or the terminal. But using PyCharm IDE also, we can run these tests inside the PyCharm IDE. So let's see how we can run those tests which we have written using PyTest using the PyCharm IDE. So as you can see here on the left hand side, I have a class, and on the right hand side, I have written some tests which are related to this class. Now I want to run these tests which I have written here using the PyTest inside the PyCharm IDE. So for doing this, what I need to do is, first of all, I need to install PyTest package inside the PyCharm IDE. So you can see here when I try to import PyTest inside the PyCharm IDE, first of all, it will give me this red squiggly line, which means that PyCharm is not recognizing this PyTest package till now. So let's first of all install this package. So just click on File and then click on Settings, and then go to the section which says Project and then your project name. So project name. So I'm going to click on this and then go to the project interpreter. Now as you can see here, there are some packages which are already here, and we want to install a new package which is PyTest. So I'm going to click on this install or this plus icon here, and then I will just search for PyTest, and the first option you will see here is PyTest, and you can see this will be the version which will be installed on our PyCharm IDE. So what I'm going to do is I'm going to just click on this button. Let me just move it a little bit above so you can see this button. So I'm going to click on this install package button, which is going to install PyTest package inside my PyCharm IDE. And once this PyTest package is installed, you will see this message which says package PyTest installed successfully with the green highlighted text. That means PyTest is installed. So you can close this window. So I'm going to close this window, and you will be able to see this PyTest now is added to your project interpreter. So now when I click on OK, and I will wait for some time till this process has been finished, and then after some time you will see this red squiggly line under this PyTest is gone. So now our PyCharm IDE recognizes this PyTest package, and now we want to tell the PyCharm IDE that we want to run the PyTests. So for doing that, once again I will click on File and then go to the Settings, and then this time I will go to the Tools. So just click on Tools option, and when you scroll down you will be able to see this option which says Python integrated tools. So just click on this, and on the right hand side you will be able to see under testing that default test runner by default is unit tests. So we need to change this to PyTest. Okay, so just change this default test runner to PyTest and then apply and then click OK, which is going to tell PyCharm IDE that we want to run the PyTests. Now as soon as you are finished with the setting of PyTest on your PyCharm IDE, what you can do now is you can right click on the file where you want to run PyTest. So this is my test_math_func.py file where all my tests are there. So just right click on this file, and then you will be able to see this option which says run PyTest in the file you want to run the PyTest. So just click on this option which says run PyTest in the file, and as soon as you do this you will be able to see this window which is for the PyTest, and you will be able to see all the tests which have been passed on the left hand side and the terminal output on the right hand side. So let me just maximize this window here, and on the right hand side you will be able to see the output. So we have run the tests on this file, and because I have some output which is a print output, as you can see here, print statement here which is responsible for printing this line, and also I have this print statement for teardown. So this teardown is printed using this print statement. Also you will be able to see two dots here, which means we have two tests inside this file which ran successfully. So let's add this verbose flag inside our PyTest using PyCharm IDE. So once you ran your PyTest using PyCharm IDE, you will be able to see this drop down menu here which says PyTest in whatever file you are running your PyTest on. And just click on this file, you will be able to see this edit configuration option right away after first run of your test. So just click on this option which says edit configuration, and then you can add the arguments which are additional arguments like verbose or -s or whatever option you want to provide here using this additional arguments option. So let's say I want to provide this -v option which is for verbose, and then I will say apply, and then I will say OK, and then I'm going to run the test once again, either clicking on this button or right away from this button. So let me click on this button, and once you ran your test you will be able to see the verbose output on the right hand side. Let me just remove these print statements because they are just not looking good on the tests. So I'm going to just remove the setup and tear down print statements from here, and I'm going to run the tests once again, and then you will be able to see the correct verbose output here. Now if you want to see all these tests which are passed or failed on the left hand side using these green or red circles, then you can click on this green circle at the top here. So once click on this green circle, and you will be able to see the list of all tests which are there inside your file. So this is the script name, which is test_math_func, and these are the two tests which are there inside this test script. So you can see the first test is test code data, which is this one, and the second test is test mark data, which is the second test here. You can also run these tests individually. So you can right click and then you can just say run test, which is going to run only one test which you want to run. So once you ran this only one test, you will be able to see on the top that only this test has been running. So in order to run the whole Python script for the test, you can once again select this option, which is Py.test in whatever test script you have. So just choose that and then run it once again. It will run your all the tests once again, and you will be able to see all the tests here. So in order to run individual tests, you can just right click and then run those tests. But remember that you need to change this option again from here. Also, if you want to run the test by just hovering over the test, so this is the test. Let's say I want to run only this test. So you can just hover over this test and then right click and then just click on this option, run Py.test for this test, which is going to run only that test. So once again, I'm going to select this option for the whole file, which is going to run all the tests once again for the Py.test using PyCharm IDE. So this is how you can run your tests which you have written using Py.test using PyCharm IDE. I hope you've enjoyed this video, and I will see you in the next video.